Okay, today the September 16th, 2025, and let's get started from the agenda. The first thing I want to have a quick think for the features. We already, let me share my screen. Okay. I want to think the feature for so far we have planned in the next release. Sorry, I don't know how to. Hey, sorry. Okay. So here is the backlog board. So let me see. Here you can see in this column you can see the features items planned in the release 1.16. The first feature I think still the multi components workload scheduling. In the last release we have a in me we have finished part of the resource interpreter feature, and in this release I hope we can finish the next scheduling part. So far I just list some tasks for the resource interpreter. This part mostly focus on the webhook interpreter. And thank you, Wei Cheng. I think we almost finished this part so far.
So out of curiosity, if you were to enable the multiple component scheduler feature gate right now, the component the component requirements will populate in the resource binding, but will the resource estimation break, or will it automatically call the older get replicas interpreter?
I think currently it will break.
It'll currently break. Okay.
If we enable that currently the interpret component will take precedence over take replica. So it will not have any replica for that specific resource.
Okay.
It will only break for that specific resource, to be more specific.
Yeah, makes sense. I was taking a look at the calls that we make to the scheduler estimator servers, and I didn't have time to check like what we actually package into the request. But my understanding is that it just takes like the replica requirements directly out of the resource binding, and packages that into the request. So at the moment, I mean, Wei Cheng, if that PR is almost finished, then maybe we don't even need to think about doing this. But like, perhaps an easy fix would just be calling get replicas for the CRD if it doesn't exist in the resource binding. But I think you have the interpret component operation already published, so I'll just wait for that change.
Okay. Yeah. I think I will start working on the part two. So I'm trying to figure out the iteration task for this week, and yeah.
Okay.
Oh,
In order of I guess importance, is that the first thing that we'll be working on?
Yeah, I think maybe not the urgent thing, most urgent thing. I mean the biggest feature planned in in this release. For example, we have some bug need to fix more. So I think, but the bug fix not listed in here. So in my opinion, bug always have uh, the most priority than feature. So
Yeah, fair enough.
so the next feature is the PDB support in the Karmada operator. So Joe has sent the proposal, I think, 2 release ago, but the implementation has been delayed. So I think we can finish this release. So far, we already have a PR in review. So another thing is not about the feature. It's the infrastructure upgrading. You know, we are using the Pro to manage our PRs and issues. So we are going to upgrade the Pro, including upgrade the cluster we are hosting the Pro. And also we will adopt a new tool to manage GitHub access. We have currently people request to join the GitHub team. We need the administrator to send the invitation to them. So I hope we can have a to automation these things. And the other thing is about we need more labels for the repos for classify the PRs issues and so on. Uh, Another thing is Joe's proposal. We hope to improve the contributor experience. Maybe we can, maybe I'm not sure yet. Maybe we can have a automatic merge strategy for PR, and we don't need to ask the contributor to squash and tidy their commits. So this is the infrastructure, and then another thing is the about the static bit feature. So far we have met a lot of users. They are using uh, the static wait feature uh, for the application high availability. So we also have some feedback, and we need to enhance this feature. So I think we can review the current feature and figure out the gaps and limitations, and maybe we also can have a best practice documentation to help users uh, use use this feature correctly. Yeah, this feature. So actually, um, recently I have been uh, working on this feature now. So, first thing, I'm trying to fix the this issue. Yeah, I'm trying to fix this issue. Okay. It's the next thing is about the summer OSPP program. This program similar to LFX program, but the host is in China. So yeah, they are small features. So I think we have just 2 weeks. The two. I mean, the feature list here doesn't mean we can only have this feature in this release. Once we have figure out the more features, we can move the features in this release too. So actually, I'm looking forward to the next feature Mihashi going to discuss multiple this anti-affinity feature. So Mihashi, are you going to take away?
Yeah, so I published the official proposal for workload anti-affinity as well as affinity on GitHub, and I was wondering if anyone has been able to take a look at it. I remember we went over the initial proposal. This was a couple months back, with Kevin included in that meeting as well. We got some good feedback. So essentially, the question becomes, should I just ping those individuals to take a look at the proposal? Would you want me to go over it right now? Like, what's the best way of reviewing this?
I think we can have you can maybe you can introduce the proposal here and
Okay, let's do that then. Cool. So this is the current state of the proposal. Starting from the top, as to what the motivation behind this is. Currently, Karmada's propagation API does have pretty fine-grained scheduling configurations. However, in the case in which users may want to ensure that their workloads exist in different clusters, that API isn't as rich at the moment. Now, you can duplicate a resource across multiple clusters that's supported currently, but the problem is if, for instance, you need to control two separate CRDs using two different deployment YAMLs. In that case, Karmada treats them as completely independent, and there's no current way to ensure that those applications will not be scheduled on the same cluster. So the goal for this proposal is to extend the propagation policy API to support this type of workload anti-affinity. And we've also added an additional use case for workload affinity, just for cases in which users may want to have co-located resources or services running on the same cluster. So for us, at least in our use case, this provides us with high availability for data processing pipelines. In the instance that maybe one data center goes down, users who have very low tolerance for downtime will want to make sure that their other application is running on a different data center. Meanwhile, Karmada will be able to take care of failing over the other application to another cluster, at which point it can start to recover as well. So I've divided the proposal into several sections here. First, I'll talk about the propagation policy API changes. So this will be adding a workload anti-affinity and workload affinity fields. I'll also briefly talk about the cluster info, cluster snapshot enhancements. So in order to support this type of affinity or anti-affinity, we need to start keeping track of affinity rules when we're gathering the clusters or the feasible clusters to which we'll be trying to schedule workloads to. So for instance, based off of the topology key, in this case, the cluster itself will probably be the topology key. If a workload is trying to get scheduled to a specific list of clusters, Karmada would check a set of clusters that match that topology key for that workload and check if there's a workload in one of those clusters that violates its anti-affinity or affinity rules. And then obviously we'll need to make changes to the scheduler as well as add in a affinity/anti-affinity filter plugin. For the user story, it's probably best to start with our use case. So as a user of Apache Flink, there might be cases where your data pipeline has very low tolerance for downtime. This is especially true in production environments. We currently have both application and cluster level failover enabled. But in both cases, even if, for instance, you were to have an instantaneous failover, which in most environments we know that this will never be true, your failover time is still going to be bound by the amount of time that it takes for your application to get back to a running state. So let's say the time that it takes for an application to come back up and start actively processing data is 2 minutes. Let's say that we had a perfect system in place that will automatically fail over applications the second that a cluster goes into a bad state. Well, your application would still be down for 2 minutes because it takes that much time for it to recover from its previous state and start actively processing data. And so even in those cases, you may have users who can only tolerate a couple seconds of downtime. And as a result, you need to start thinking about other more robust failover mechanisms. So in our case, we have users who deploy multiple versions of the same pipeline across multiple clusters. So if one application or data center goes down, you have an identical pipeline that's processing the same data that some sort of curator will be able to flip the switch and start listening to that actively processing data as the leader. So this results in a couple seconds of failover time, which is a lot more manageable. That said, in order to support that use case, we need to ensure on the Karmada side that two duplicate pipelines are never scheduled to the same cluster. Because currently, if a user is deploying these two linked data pipelines, Karmada will not know that they can't exist on the same cluster. So what I've created in this image below is essentially two duplicate pipelines that are getting scheduled for high availability purposes. Karmada is going to make sure that during the scheduling phase, let's say workload 2 is getting scheduled, it will notice that both workloads share the same label key for Karmada IO/group, which is high availability pipeline. And as a result, it knows to filter cluster A out of the feasible clusters. So workload 2 will only be scheduled to one of cluster B or cluster C. Does that use case make sense?
Yeah, I think very clear. But I have a question here. Do you mean the cluster failover feature cannot meet your downtime requirements?
In most cases, it's okay.
Mm-hmm.
Like for instance, we use the cluster taint policy, and then we have taint tolerations that are set on the workload, right? The user can configure what type of failover they need, right?
Mm-hmm.
In some cases, this can be set to 5 minutes. In some cases, it could be set to less. However, what I was mentioning with my example is that even if cluster failover happens immediately, there's still time that it still takes time for the actual pipeline to come back up and start running again, right?
Mm-hmm.
So that's almost like built in, like you have 2 minutes of downtime because that's how long it takes for your application to reschedule, and to like come back up and start running again, right? Um, and we have users who cannot tolerate that type of downtime, like
Mm-hmm.
regardless of how efficient the Karmada rescheduler is, right? Um, so in our case, we require these users to deploy multiples of their pipeline. And then they handle either you have two duplicate pipelines that are publishing to the same database, such as like a Redis, and it handles like the deduplication of their pipeline for them, or they're using something like a Zookeeper curator who is keeping track of which pipeline is the leader. And if one of the data centers goes down and Karmada decides to reschedule that application, Zookeeper would notice that one of the leaders was lost, and then it'll elect the other running pipeline and immediately start processing from there. So it's on a case by case basis, but there are some users who the existing failover mechanisms will never be efficient enough for them.
So, do you mean the class failover feature will used for part of the user, and the anti-affinity feature will be used for another part of a user, right?
No, anti-affinity will be used by all users. It's
Mm-hmm.
it's just important because the duplicate pipelines that I'm talking about, they
Mm-hmm.
lose all of their efficacy if they're scheduled to the same cluster,
Yeah.
right? Because you need two duplicate pipelines running on two different clusters for the instant failover to work. If they're both on the same cluster, they both have to get rescheduled if the data center goes down, and then you're out of luck. You have to wait for those applications to come back up, right?
Okay. Okay. I get. So I get you want to uh, duplicate pipelines, and at the same time you still want the cluster failover feature work, um, right?
Yeah, so I mean, like ideally, assuming we have three clusters in the cluster set,
Mm-hmm.
um, you have two workloads that are running on separate clusters. During
Yeah.
failover, like let's assume that cluster A goes down.
Mm.
During failover, Karmada already will filter cluster A out of the equation because it's failing over from there. But
Okay.
when the application gets rescheduled, the feasible clusters, it should filter cluster B out of the equation as well, because
Okay.
the other duplicate workload is already scheduled there. So instead, we would expect workload 1 to be rescheduled to cluster C instead.
Yeah, I see. Yeah, I see. That makes sense. One more question is, I didn't follow how the how to select the leader pipeline. So,
Oh, I was just giving an example. I know we have users who rely on Zookeeper to select the leader of their
mhm,
pipeline. Um, it's more of like a switch as to where the downstream client is reading from. So for
yeah,
instance, there's a user that I know that has two duplicate pipelines and they're publishing their processed data to two separate HBases. Um, and from there, they have a separate Zookeeper kind of latch that's checking, okay, which is the pipeline that we're actively reading from, and what is the pipeline that we're presenting to users. If, let's say, in this instance, workload 1 is the leader and cluster A goes down, then this workload, its heartbeat that it's sending with Zookeeper will expire. And at that point, Zookeeper will re-elect the leader to be workload 2, which would just switch which HBase the client is reading from.
Yeah, I see. Sorry, I also have another question. Is once let's see the cluster A is go down, and the workload in cluster B, that the workload in cluster B can resume from the 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 last checkpoint else?
So workload, I guess I see why this is confusing, because I'm saying that they're duplicate workloads. They're actually two distinct applications that just so happen to be processing the same data. So
Okay.
in this case, the user would be deploying two separate Flink deployment YAMLs. They'll be writing checkpoints to completely different buckets or completely different directories, and they would all be managing their state independently. So the state of workload 1 is completely independent from the state of workload 2.
Okay. Okay. I see. The two application have they are writing they will write the data to database, right? I see. But they are consuming the same data flow.
Correct. We have users who either are running these two duplicate pipelines reading from like the same Kafka source, and they use partitions. So like the data points sometimes go to different applications. Sometimes they use different Kafka sources. And so the two Kafka sources have duplicate data, and they're both getting fed into both applications. So it depends on how the user sets it up. But the what's good to understand is that in this case, like the state that's maintained by both applications is completely independent. So like if cluster A went down, workload 1 would fail over to cluster C and it would resume from its own latest state. It has nothing to do with workload 2.
Yeah.
Yeah, that makes sense.
Okay. Interesting. So thank you.
Oh, no.
Yeah.
Yeah.
Okay. And then moving forward, I added two quick stories just for affinity. One was for, let's say, like very large training jobs. There might be use cases where the user starts to run into memory or batch size limits where data sets don't fit into a single worker's GPU. And the user may want to shard training data across multiple smaller training jobs. And so these jobs would ideally be scheduled to the same cluster, which in this case, the Karmada scheduler could handle this by setting affinity rules. But that's just an example. There could be other cases where, for instance, you want co-located workloads that speak to one another. And so as a result, you would want to prefer those get scheduled to the same cluster just to minimize latency.
Yeah.
For the API changes, so like my focus here is workload anti-affinity, but I think the way that this is implemented is pretty, like it naturally follows to do it with workload affinity at the same time. So what I did was for the placement struct within the propagation policy, I've added a workload anti-affinity and workload affinity fields. I can start with workload affinity first. So workload anti-affinity, this just represents the inter-workload anti-affinity scheduling rules. So I've included required during scheduling, ignored during execution. So this just means this is a hard requirement. So Karmada will filter out clusters that do not satisfy the workload affinity term.
Mm-hmm.
Whereas the preferred during scheduling, ignored during execution is just a soft preference. So this can be useful when users don't need the hard limit and instead they want to set weights as to how important they want this affinity or anti-affinity rule to be.
Mm-hmm. Yeah.
So this is workload anti-affinity for, oh, this needs to be updated, I think. But for workload affinity, this is pretty analogous. It's the same thing. So for hard requirements, this must be satisfied. For preferred during scheduling, this is just a soft requirement.
Yeah.
Now for the workload affinity term and the weighted workload affinity term, this is shared by both workload anti-affinity and workload affinity.
Mm-hmm.
And so the way that this works is there will be a label selector. So this is just a label query that's made over a set of resources. If it's null, then the workload affinity term matches no workload. And then additionally, I added a label selector. So the values of this will be determined from this workload's labels. So for instance, if we set ha.karmada.io/group, we would match workloads sharing the same group value. So we're essentially looking at cases in which we would want, like in this instance, the user would label their workload with Karmada IO group, and then Karmada would notice, oh, there's another workload with this exact same label value already present on this cluster. Let's filter that out during the scheduling.
Mm-hmm.
Namespaces is optional. This is just referring to which namespaces the term applies to. Namespace selector, it's also the same thing. So this is a label query over the set of namespaces that the term applies to. If you wanted to do like a union of different namespaces. And then finally, this is the cluster label key. So this defines the colocation domain. So essentially, topology key is going to be the way that Karmada determines what cluster or essentially which domain you're trying to set this affinity or anti-affinity for.
Mm-hmm.
And then finally, the weighted workload affinity term, it's just a wrapper. So it contains the workload affinity term in it, but it also has a weight. So the higher the weight, the stronger the preference.
Mm-hmm.
Now, an example of this usage for anti-affinity. So I created a propagation policy here. This is high availability Flink deployment. It selects the Flink deployments. And then under placement, I've defined a workload anti-affinity rule. This is a hard requirement. So I want this to be required during scheduling.
Mm-hmm.
What it'll do is it will select only applications that have this app tier prod set on their YAML. And then additionally, this will check for equality on this workload's label. So Karmada IO group. So this is how we're going to group applications with one another. So if this Flink deployment is matched by this propagation policy, and it contains this karmada.io group label, let's say we have like indexer job, then in the future, if there's another Flink deployment that gets applied that also has this group under indexer job, Karmada will filter out any cluster that matches this topology key with an application that already has an indexer job scheduled to it.
Mm-hmm.
Does that make sense?
Yeah. Yeah.
Okay, cool.
Hey, Mihash, I'm curious, like, what's the clear difference between this and the spread constraints?
Spread constraints will only work if it's for an individual resource. So for instance, if you're trying to spread replicas, like divided replicas across clusters, then that will work. However, in our case, each Flink deployment is its own YAML, and there is no link between separately applied YAMLs. Like if I set a spread constraint to be across like clusters, I mean, correct me if I'm wrong. I haven't been able to use the propagation policy API in order to spread separately applied resources across different clusters.
Yeah, I haven't tried yet, but yeah, but I remember it also used the purpose of it is also for HA, like it's also for like spread the workload to multiple cluster, and then we can make sure like it has a like specific group of the workload. But yeah, I can double check. I'm just curious. It's because it seems like yeah,
So,
never mind. I will check it.
so the issue there is, let's say I have two distinct Flink deployments, because your spread constraints would work if I were to duplicate the exact same spec across different clusters. For instance, let's say I set my gosh, what would
Oh,
the name be?
you mean the user will create two like Flink deployments, and then they want to
Correct.
make sure they will separate
Correct.
between. Oh, okay, got it. Okay, thanks. Yeah, spread constraint will only works for a single deployment and separate its replica. Got it.
Yep.
Yeah, thanks for the clarification.
Yep. Okay. Um, so hopefully that clarified things. And then lastly, code changes. I don't know if it's wise to go over this in detail just yet because I don't want to get into implementation details before we've decided that the API makes sense. However, based off of some investigations that I did already, I think a lot of the way that this can be implemented um, can borrow from the concepts of how this is implemented in Kubernetes. So the way this would work is currently, I think in Karmada, we have something called cluster info. And this is meant to kind of contain aggregated metadata to all the clusters that we currently have in the federation. So what we would want to do is actually expand that to include specific affinity rules. I don't know if resource binding is the correct way to go about this, but essentially we need to start keeping track of resource bindings that have required affinity or anti-affinity rules. And then within the cluster snapshot, um, we should be checking and filtering out any clusters that would not be feasible due to violations of anti-affinity rules or affinity rules. So in order to do that, we would also need to make a change to the scheduler in order to call the workload affinity filter plugin, and that plugin would match clusters based off of the topology key and see whether that cluster satisfies workload anti-affinity or whether it satisfies affinity based off of the rules that are defined within the resource binding. But truthfully, I think this might need to get reinvestigated. I haven't updated this part of the proposal in a while. I was hoping to get some feedback on this before determining like the right implementation strategy.
Yeah, I think it makes sense to me to postpone the code changes before we have agreement on the API part. So far I think the use case in this proposal is solid. So for the API, I think mostly I don't have comments now, but I think I will talk to Kevin and let him to take another look. He is the author of the affinity feature in Kubernetes. I think he will be interested in this feature. And also, I talked to Kevin uh, uh, about this feature about a month ago. He shared some insights for the code change part. So what I get from him is the implementation will be very heavy. For example, when you try to select the cluster, you need to know all the workloads running in this cluster, and you need to check workloads by workloads and to figure out if the cluster should be selected or should not be selected. And so, yeah,
Yeah, we'll need to be smart about how we maintain that metadata. I mean, it could just be that during scheduling time, once the scheduler decides to add the cluster to the resource binding, we could then update like the cluster info snapshot to map specific workloads to specific clusters that they've been scheduled to. So that during the next iteration of the scheduling queue, the next workload, if it has an affinity or anti-affinity term defined for it, it would be able to reference that cluster info snapshot and guarantee that it's up to date. But yeah, I will send a message to Kevin on the proposal
yeah,
and
yeah.
ask him
You
to
can
take a look.
you can just CC him in the PR.
Okay. Yeah, that'd be great.
I remember we shared a link for the second user story, right?
Yeah, I had added in that as a bullet. It's like the Ray service. I just didn't mention that during my explanation. But yeah, Wei-Cheng, if there is a use case that's more fleshed out, I can add that as a separate story item.
Yeah, I will take a look and also review the proposal.
Okay, sounds good.
Yeah, also regarding this, just curious, since also Owen is working on the Ray related support, and Ray provides not only Ray, also like Ray and Spark all provide like in cluster no scaling. Just wonder, does Karmada support that? I know Karmada support like federated HPA for deployments, and just curious about if Karmada also support like reflecting replica numbers back to the resource binding.
Reflect the replica numbers, right?
Yeah, because like Spark, because also like who is it? Like Spark team also asked me if it's supported because they are Spark job. also enable like auto scaling in a single cluster.
Mhm.
And like in the future, after they also want to adopt the federated resource quota. So they are asking if this kind of like auto scaling, which will increase the resource usage, will reflect back to the Karmada, so they can have like an accurate approximation or accurate calculation of those usage.
Yeah, the replica number located in the status part or the spec part.
I think there will be both. I think it will be status part. Status will be the more accurate place for the actual numbers. But yeah, Owen, feel free to correct me if I'm wrong. I remember for array, it will also reflect in the status part. It will have like desire and the actual one.
Yeah. So far, the resource interpreter can sync the replica back to Karmada, and I don't know if we can use that replica info to calculate the resource quota. Maybe. Have you ever run a simple test for this?
Oh, not yet.
Or
I will try it like in this weeks in these 2 weeks. Just want to just want to take the chance on the meetings to ask about it. Yeah, but I will
yeah.
try that.
I see. You mean the Spark job, right?
Yeah, Spark and Ray.
Spark and Ray. Okay, that will be rely on the feature we planned for the in the LFX program. So after that, we can have the built-in interpreter. So that would makes it easier for run the test, I think.
Yeah, yeah. Thanks. I will try it
Mhm.
out on my side as well. It's just
Okay.
the one, forgot the name, but
Mhm.
I think you met him in the KubeCon. Uh,
The KubeCon North America, right?
I I think it's in EU, like
EU.
the
Oh
Spark,
yeah,
the team member in Spark team, and he keep asking me if it supports it. So I right now I will start helping them out and trying out if it supports their use case.
yeah. I think I will be present at the KubeCon EU next year, and then currently I'm still thinking the the CFP thing. Um, so if you have any proposal, you want to me as a second speaker, so just talk to me.
Oh, got it. Yeah, sure.
Mm-hmm.
Yeah, thank you.
Mm. Okay, since we don't have any other agendas, oh, for the next meeting, I'm not sure if I am still able to hold because the next meeting, we are going to have the public holiday next time. So, but not sure for now because the next meeting day is just the day before the holiday. So I'm not sure. I'm I be, will go home before the holiday. So
Yeah, no worries.
Okay, anything else? No.
So,
Okay. See
Thanks a
you
lot.
next time. Mm-hmm.
Thank you.
See you.
Take care.
Bye.
Take care.
See you.
Bye.